So, good afternoon. I am incredibly honored to join the panel today and address you all as part of swissnexDay 2019. And my job, as Reto mentioned, is a research engineer at the Space-Enabled Research Group at the MIT Media Lab. And as part of my role within the Media Lab, I have the privilege to travel to different countries and communities and really ask them what they see is the future of space technology. And often they conjure up images of discovery, deep space exploration, terraforming Mars, and often also Twitter battles between billionaires. That was a joke, you can laugh. The space industry is on the verge of a new space age where technology and services are as diverse as they are innovative. But more often than not, we get asked the question, with so many challenges here on Earth, why should we bother about space? So at Space Enabled, we try and address that question. And our mission is in advancing justice in Earth's complex systems using designs enabled by space. Now, justice and space are two words that don't often go in a sentence when we talk to the space industry. But we define justice in two ways. Firstly, one in which all countries are progressing towards the Sustainable Development Goals. And secondly, ensuring that every country and community has easy access to space technology that allows them to progress towards the SDGs. Now, space technology has the potential to bring tremendous benefit to countries to progress towards the SDGs. Now, with a show of hands, how many of you are aware of these 17 colorful boxes? I hope I see lots of hands. Perfect, excellent. Very happy to see that. So the SDGs, of course, were unanimously adopted by the United Nations in 2015 and serve as a great summary of some of the key challenges that we face today, including meeting basic human needs, as well as ensuring the longevity of our planet. Now, there are 6 space technologies that we at Space Enabled believe help countries and communities progress towards the SDGs, including Earth observation, positioning and navigation, human spaceflight, microgravity research, communication, space tech transfer or spin-offs, which we see quite often, as well as innovation from research and education. Now, you and I might use many of these technologies often on an everyday basis, but the reality of the situation is that there are barriers that exist that limit the potential use of space technology around the world. And often countries and communities have trouble accessing these space technologies, maybe because they're expensive, maybe because they lack the resources or expertise in order to do so. So we ask the question, how can we redesign space technologies to ensure they have an equitable use around the world? Now, achieving the SDGs requires an accelerated action by stakeholders at all levels. So through our research, we explore coordination mechanisms as well as resources that are initiated and implemented through multilateral development agencies, government agencies, entrepreneurs and NGOs, as well as, of course, academia being MIT. And we do this by applying a cross-disciplinary approach using the 6 methods here that I have on screen. And this really allows us for an engagement of complex socio-technical systems that have emergent properties, operate under uncertainty, evolve often outside the designer's intent, and include non-linear interactions between humans, society, culture, environment, technology, and policy. And we use this cross-disciplinary approach because we realize that SDGs are not just interlinked, but they're also multifaceted. So let me share a few examples of how space technology is already helping countries progress towards the SDGs. Earth observation being one of the most frequently used, or one that comes to mind when we think about some of these space technologies, as already mentioned. But Earth observation helps us track global change, both in high resolution and often in real time. And once we combine Earth observation data with demographic as well as statistical data, it becomes very useful for governments, not just in real time, but also to plan where their societal development programs need to be going. Now, this is an image taken from NASA's EquaMODIS satellite in the beginning of November. And this shows the unprecedented wildfires that were happening on Australia's east coast. And when this picture was taken, I was somewhere around there, just a few hundred kilometers from where the fires are. And I show this picture, one, because it's quite close to home for me, but also the fact that this is real life situation where space technology is being used on a day-to-day basis. Now, data from infrared satellites can also be used to produce maps such as this. This shows fire hotspots, which essentially looks at warm areas of the land in comparison to the surrounding areas. And that data can be implemented into a real-time web application such as the Sentinel hotspots, again, for users to see where the fire is going to be, how are they progressing, what is the extent of the fires, and helps government agencies on ground validate this information, but also send their firefighters to specific areas so that they're accounting for their resources as well. And of course, with fire comes smoke. These were the smoke produced really went down from the South Atlantic, crossed to South America, and then over to the, no, did I get that? Thank you. Yes, it went across the ocean, is what I'm trying to say. And we can track that using space technology, right? So another example I want to show is microgravity research and space spin-offs contributing to the SDGs. And with microgravity research, it's really the study of how humans, plants, and animals are affected when there's no gravity. And recently, there's been discoveries of how to grow plants in space or to pack more nutrients into plants. And this is very important when we consider long duration missions. So if we're going to the moon and Mars, there's only so much food that we can take with us, right? Us being me, the astronaut, that we can go to Mars with. So essentially, we need to learn how to grow food in space. Now, when we consider that one of the greatest challenges on Earth is the ability to provide food, nutritious food, to the expected 9.7 billion people on Earth by 2050, this sort of technology is highly important. And so from a NASA study and researchers, what they've discovered is a product that they've now named BAM-FX Mineral Solution, where essentially they've realized that by increasing the zinc and iron content of a plant, it actually has an increase in the crop yield of that plant. So researchers have shown through this product that by addition of zinc and iron, we can increase the crop yield by approximately 25%, even if there's 25% less fertilizer used. Now, when we think about farmers in remote areas, that brings down the cost to the farmers, and this is particularly important in areas of malnutrition as well as food scarcity. So let me quickly talk or give you a few examples of what we do at the Space Enabled Research Group at MIT. And the first example I'd like to mention is our partners with Greenkeeper Africa in Benin, more specifically in the city of Cotonou in West Africa. So Greenkeeper Africa is an entrepreneurial firm, so a startup based in Benin. And like other parts of Africa, Benin is affected by an invasive water hyacinth plant. Now, if you can see, it actually has a really beautiful purple flower. But the fact is, this plant grows in a thick bed of vegetation that completely blocks rivers and waterways. And here you can see how the boat is struggling. So farmers actually struggle to get from A to B. It also blocks trade, economic growth, travel and tourism in the area. It also decreases biodiversity and increases the risk of flood. In addition to that, if you didn't think it was bad enough, it's also potential for malaria breeding mosquitoes to also breed around this plant. So Greenkeeper Africa have come up with an innovative solution where they've realized that by collecting this plant and drying the plant, they actually turn it into a fiber. This fiber is 100% organic and has the ability of absorbing many times its weight in oil. So Greenkeeper Africa are really looking at this challenge in many ways. One, how can they eradicate the invasive water plant? Two, how can they mop up oil spills that are frequent in this area? And three, by employing the farmers to actually go out and help harvest the invasive water plant, it's promoting additional jobs for the coastal communities. So we work with Greenkeeper Africa in this integrated design process, as I'd mentioned before. Firstly, to look at satellite Earth observation. So this is often open data, depending on the resolution, to see where the water hyacinth is and track the trends of the water hyacinth. So how is it growing and where is it growing? How is it moving on water bodies? We also have a student, Ufoma, who's been to Benin to do aerial observation. So we're using drones to validate the data that we're getting from satellites and really teach the local communities and build their capabilities with regards to using this technology. And we're also doing in-situ testing. So looking at what sort of parameters affect the growth of this invasive plant. Maybe it's the salinity of the water, maybe it's temperature, maybe it's flow rate, or even the local weather conditions. So really by having a combination of all of these data sources, we can put through an interactive map a real-time solution for the coastal community to see where they can go in a certain time of the year. Maybe they have employment prospects where they can harvest the plant, et cetera, et cetera. So it's really all about tangible solutions. Another project that I'm very excited about, it's a recent project, is working in Tanzania in Dar es Salaam. I was in Dar es Salaam just a week ago, where we were called in by the local government of Dar es Salaam, where they've realized by the year 2035, their population of Dar es Salaam is going to be 13.4 million people. It is one of the fastest growing African cities. So we're showing them how to use geospatial data. So in particular, we're looking at formal transportation in combination with the informal transportation system. So they've recently administered a formal, what they call a bus rapid transport system. So we're looking at, firstly, where are people living in Dar es Salaam? How are they getting to the bus stops? Why are they using the bus stops? And are there certain areas in Dar es Salaam that it floods year in and year out, so they know not to build roads there or to build more resilient roads there? And this, of course, means that it touches on SDG 9, SDG 11, sustainable cities. But the fact is, people need transportation to get into the economic areas of Dar es Salaam. So that also touches on decent work because people need to get from A to B. Now, at Space Enabled, we also want to consider, when I first mentioned our mission, we talked about justice. So we want to also consider the equitable and just access to space. Now more than ever, there are an increasing number of space actors, and even more so, emerging space nations. Last week, after being in Tanzania, I had the remarkable opportunity to travel to Addis, Ethiopia, where I joined a conference where they were talking about the initiation of an African space agency. So very similar to the European Space Agency, this is a continent agency that has 55 member states. That's pretty incredible. And of course, you have the heavy hitters there, the South Africa, Nigeria, Kenya, Egypt, who already have great space capabilities. But Ethiopia, for example, will join these countries to launch their first ever satellite this month. So to have 55 member states join the space race, in addition to the proposed mega constellations that happen, we need to think about how we keep the space environment sustainable. And one way we're doing this is by looking at reconfiguring the life cycle of satellite missions. We are looking at using candle wax or beeswax as an alternate to the traditional propellants. Now, candle wax, beeswax, what? I see some confused faces. I like it. Firstly, beeswax is a byproduct, right? People throw it away because what they want is honey. Candle wax is easily accessible. It's very cheap and lightweight, and it has the same properties as a traditional propellant. This means that the cost of developing and launching a satellite is reduced, which means that the number of entrants to space increases. And another way we're looking at it is not just allowing more countries and communities, academic institutions to access space, but we also want them to think about the end of life cycle. So at the moment, what we're doing is really looking at how we can reuse or repurpose this candle wax, which currently is a thermal insulation layer, and use that as a fuel to deorbit their small satellite at the end of a life cycle. So they push off into another orbit or push towards Earth, where they then are burned up in the Earth's atmosphere. So I've spoken a lot. I hope I've given you a little bit of an insight into how space technology has been and is currently being used for the Sustainable Development Goals. But as we think about the future of space, I really urge you not just to think about the technology and the development, but the policy issues that come with that, the local contextual factors, and the fact that the end users also need to use this technology. And the fact is, barriers still exist. So I hope you can all help me in identifying, recognizing some of those barriers, and continuing to have this conversation about how we can better utilize space technology for the SDGs. Thank you very much.